Welcome, learners. Today we are diving deep into KTO2, which is corporate governance and risk management. Today we will explore every principle, standard, process, and governance structure described in your learning material. As we unpack these topics, I will guide you through real production floor scenarios, especially those who experience as production supervisors. Let's begin by grounding ourselves in what governance and risk really mean in a manufacturing environment. With that foundation set, let's move into the standards that govern organizational behavior. Let's begin. Now, it is important to remember that standards are described as the rules, frameworks, and guidelines that shape how an organization operates. Let me simplify this. Standards ensure that everyone follows the rules consistently and correctly. International standards such as the ISO 31000 focus on risk management. They teach organizations how to identify and manage risks during structured processes. In a manufacturing plant, following ISO 31000 means that your risk registers, incident logs, machine maintenance schedules, and escalation procedures must align with global best practice. National standards include South African laws like the Occupational Health and Safety Act. These laws protect workers by ensuring organizations manage machine safety, hazardous materials, emergency procedures, and safe working conditions. Organizational standards include international policies, SOPs, shift handover procedures, quality protocols, disciplinary rules, and reporting structures. These eternal rules guide production supervisors in leading safely, ethically, and compliantly. Now that we understand that these standards guiding us, let's explore the principles that shape risk management itself. Risk management principles create the foundation for how risks are handled throughout the organization. I'm going to explain principles such as integration, structure, inclusivity, and continual improvement. In a production environment, integration means risk thinking becomes part of every shift decision you make. Structure means risks are assessed constantly using formal tools. Inclusivity means involving operators, technicians, and supervisors in identifying workplace hazards. And continual improvement means that risk controls are reviewed and strengthened over time. Example: imagine your extrusion machine overheats regularly. Instead of reacting each time, a principle-based approach would involve analyzing the root cause, redesigning the control measure, and reviewing the change after implementation. Good principles need a strong framework, so let's examine what that looks like. A risk management framework outlines how an organization supports risk processes. According to ISO 31000, the framework includes 1. Leadership and commitment. 2. Integration into organizational processes. 3. Design of the risk framework. 4. Implementation. And 5. Evaluation. 6. Continual improvement. For production supervisors, this framework becomes visible through A. Daily production meetings that highlight risks. B. Safety audits and checklists. C. Mandatory reporting of near misses. D. Maintenance logs. And E. SOP-driven responses to incidents. This framework ensures risk management isn't optional. It becomes part of your daily leadership. With this understanding, let's walk through the actual risk management process. The risk management process as a cycle is 1. Identify. 2. Analyze. 3. Evaluate. 4. Treat. And 5. Monitor and review. Let's break this down with real production examples. 1. Identify. You look for hazards or failures that may affect safety, quality, production output, or compliance. Examples: machine vibration, worn belts, incorrect setup, or untrained operator. 2. Analyze. You determine the cause, likelihood, and impact. Example: the conveyor belt slips daily, likelihood is high, impact affects output and safety. 3. Evaluate. You rank the risk low, medium, or high. A recurring machine fault with safety impact equals high priority. And 4. Treat. You apply controls, engineering controls such as guardrails or interlocks, administrative controls such as SOP updates or training, as well as PPEs and maintenance interventions. And lastly, monitor and review. Controls are never one-off. You continuously check whether they are working through inspections, reports, and production data. Now let's connect governance principles to your roles as supervisors. Here's what they look like for supervisors. 1. Accountability. You take ownership for machine quality, safety, and reporting. 2. Transparency. You report breakdowns and quality issues honestly and immediately. 3. Responsibility. You follow SOPs, conduct inspections, and enforce safe behavior. 4. Fairness. You allocate tasks fairly and avoid bias. And 5. Ethical leadership. You model correct behavior even when no one is watching. In manufacturing, stakeholders include workers, managers, customers, suppliers, and regulators. Now let's explore governance methods and structures. Governance structures create the system that ensures compliance and accountability. These include 1. Boards and executive committees. 2. Audit and risk committees. 3. SHE committees. 4. Production supervisors and managers. And 5. Internal and external audit. Now, governance methods include policies, SOPs, performance management, reporting channels, and internal audit processes. For production supervisors, governance becomes practical through 1. Documenting shift incidents. 2. Conducting safety checks. 3. Ensuring operators comply with standards. 4. Escalating risks immediately. And 5. Upholding ethical conduct. Now let's examine the full risk cycle once more with practical manufacturing examples to strengthen your ISA readiness. Now let's revisit the cycle with detailed examples that mirror ISA-styled questions. Example 1. Machine breakdown. 1. Identify. The molding machine overheats during peak hours. 2. Analysis. Cause linked to insufficient cooling, likelihood high, impact critical. 3. Evaluate. Ranked as high risk, including safety and downtime. 4. Treat. Implement maintenance, upgrade cooling fans, and retrain operator. And lastly, monitor. Weekly checks plus production data view. Example 2. Quality failure. 1. Identify. Packaging seal not closing properly. 2. Analysis. Incorrect temperature setting and operator error. Evaluate. Medium high risk due to customer impact. Treat. Enforce SOP training. And 5. Monitor. Quality checks at start of shift to make a difference. And now we are moving on to our last example. Safety risk and oil spill. 1. Identify. Spill near the press machine. 2. Analyze. Leak from valve and it is a slip hazard. 3. Evaluate. High risk due to injury potential. 4. Treat. Lockout machine, repair leak, and apply absorbent powder. And 5. Monitor. Conduct floor inspections each shift. Let's add one short activity from the learning material to reinforce your understanding. And here is your group activity. Identify one real risk from your workplace. Then apply the 5 steps, which are identify, analyze, evaluate, treat, and monitor. Be ready to explain why your treatment option is the most effective. Take time to do this group activity, and thereafter, we will bring everything together. Now that you've done your group activity, let's see everything that we've learned in today's session. Today, you gained a deep practical understanding of governance principles, risk standards, frameworks, and full risk processes. We linked each concept to your duties as production supervisors and used real manufacturing examples to build competency for assessments and ISA. By understanding these concepts and applying them consistently, you will not only excel academically, but also lead safer, be more compliant, and more efficient production environments. Thank you, learners, for your participation and attention today. I will see you at the next session for KTO3.